Good day, everyone. Today, I will report about the four category of thermodynamics. The first one is the conversion of units to samples with solution. The second one is the Newton's law of motion, 5 sample problems with solution. The third is the pressure, 5 samples problems with solution, and last the temperature, 5 problems with solutions. So let's proceed to the first one, which is the conversion of units. So converting units of measurements. So in metric units, the metric system of measurement is based on powers of tens and uses the following prefixes. So kilo meaning 100, centi meaning 100, milli meaning 1000, micro meaning 1 millionth. These prefixes are then followed by a base unit. The base unit for length is meter, the base unit for mass is gram, the base unit of capacity is liter. So in metric units of length, metric units used for lengths are kilometers, meters, centimeters, and millimeters. So in 1 kilometer, we have equals to 1,000 meters. To 1 meter is equal to 1,000 centimeters. A 1 meter equals 1,000 millimeters. And 1 centimeter is equal to 10 millimeters. So that's the metric units of length. Here are some example about the metric units of length. So a racetrack measures 400 meters. An athlete runs 2.6 kilometers around the track. How many laps is this? So 40 meters is equal to 0.4 kilometers. Number of laps is equal to 2.6 divided by 0.4 is equal to 6.5 laps. So in the following day, the athlete completes 8 laps. How many kilometers is this? So 8 laps is equal to 8 times 0.4 kilometers is equal to 3.2 kilometers. So example of, and let's tackle about metric units of mass. So metric units is used for mass are tons, kilograms, and grams and milligrams. So for 1 ton is equal to 1,000 kilograms or kg. 1 kilogram kg is equal to 1,000 grams J. So 1 gram G is equal to 1,000 milligrams mg. So that is the SI unit of mass. So here are some example of unit of mass. So 60 bags weigh 150 grams. How much would 200 tea bags, 2,000 rather, weigh in kilogram? We can solve this problem using a unitary method. 60 tea bags weigh 150 grams. So 1 tea bag weighs to 150 divided by 60 grams is equal to 2.5 grams. Therefore, 2,000 tea bags weigh the quantity of 2.5 times 2,000 grams is equal to 5,000 grams divided by, to convert into kilogram, divided by 1,000, which is equal to 5 kilograms. So let's proceed to units of capacity. Capacity is a measure of amount of liquid that a 3D object, for example a glass, can hold. Metric units of capacity are liters I, centiliters CL, and milliliters ml. So 1 liter is equivalent to 100 centiliters. 1 liter is equivalent to 1,000 milliliters or ml. 1 centiliter is equal to 10 milliliters. So here is some sample of capacity. A bottle contains 750 ml of orange squash. The label says dilute 1 part squash with 4 parts water. How many of liters of drink can be made with 1 bottle? If the whole bottle was made up, we would have 750 ml of squash plus the quantity of 4 times 750 ml of water is equal to 750 ml of squash plus 3,000 ml of water is equal to 3,750 ml of drink. So to convert into liter divided by 1,000, so the answer is 3.75 liters of drink to be made with 1 bottle. So, converting metric units. To convert from a larger metric units to a smaller one, we need to multiply by 10, 100, or 1000. So, in 34 cm is equal to 340 mm. So, multiply. So, 0.4 liter is equal to 400 ml. 7.3 kilograms is equal to 7,300 grams. 54.8 cl is equal to 548 ml. 0.0471 kilometers equal to 47.1 meters. 0.23428 meters is equal to 342.8 millimeters. 23.51 grams equal to 23,510 milligrams. 0.085 meters is equal to 85 millimeters. Here's another example to convert metric units. 920 mm is equal to 92 centimeters. 530 grams is equal to 0.53 kilograms. 3,460 ml is equal to 3.46 liters. 43.1 cm is equal to 0.431 meters. 65,800 meters is equal to 65.8 kilometers. 526 milligrams is equal to 0.526 grams. 4,539 cl is equal to 45.39 liters. 87 kilograms is equal to 0.087. Here the sample of units of area. Area is measured in square units. Here is a square meter or 1 meter squared. So how many centimeters squared are there in a meter squared? So 1 meters is equal to 100 centimeters. So 1 meter times 1 meters is equal to 1 meter squared. So 100 cm plus times 100 cm is equal to 10,000 squared centimeters. So 1 meter squared is equal to 10,000 squared centimeters. So units of area, we can use the following to convert between units of area. So 1 kilometer squared is equal to 1 million meters squared. So 1 hectare is equal to 10,000 square meters. 1 square meters is equal to 10,000 square centimeters. 1 square meters is equal to 1 million millimeters squared. So 1 square centimeter is equal to 100 millimeters squared. So the example of units of area. A rectangular field measures 150 meter by 250 meters. What is the area of the field in hectares? So the area of field is 150 meters times 250 meters equals 37,500 meters squared. So 1 hectare is equal to 100 meters times 100 meters is equal to 1,000 meters squared. So 37,500 meters squared equals 3.75 hectares, which is to divide by 1,000. So the answer is 3.75 hectares. Units of volume. Volume is measured in cubic units. Here is a cubic centimeter or 1 cubic centimeter. How many millimeter cubic are there in a cubic centimeters? So 1 centimeters times 1 centimeters times 1 centimeters equal to 1 cubic centimeters. So 10 millimeters times 10 millimeters times 10 millimeters is equal to 1,000 cubic millimeters. So 1 cubic centimeters is equal to 1,000 cubic millimeters. Volume is measured in cubic units. Here is a cubic meter or cubic meters. How many cubic centimeters are there in cubic meters? 1 meters times 1 meters times 1 meters is equal to 1 cubic meters. So 1,100 centimeters times 1,100 centimeters times 100 centimeters is equal to 1 million cubic centimeters. So 1 cubic meters is equal to 1 million cubic centimeters. We can use the following to convert between units of volume. So 1 cubic kilometers is equal to 1 billion cubic meters. So 1 cubic meters is equal to 1 million cubic centimeters. 1 cubic meter is equal to 1 billion cubic millimeters. So 1 cubic centimeters is equal to 1000 cubic millimeters. Here are some example of units of volume. Dice are packed into boxes measuring 20 centimeters by 12 centimeters by 10 centimeters. If the dice are 2 centimeters cubes, how many of them fit into a box? The volume of the box is equal to 20 times 12 times 10 cubic centimeters is equal to 2400 cubic centimeters. The volume of one dice is equal to 2 times 2 times 2 cubic centimeters is equal to 8 cubic centimeters. Number of dice that fit in the box is equal to 2400 divided by 8 is equal to 300 dice. Volume and capacity. Capacity is a measure of the amount of liquid that a 3D object can hold. A liter of water, for example, would fill a container measuring 10 cm by 10 cm by 10 cm or 1000 cubic centimeters. So 1 liter is equal to 1000 cubic centimeters. 1 milliliters is equal to 1 cubic centimeters. 1000 liters is equal to 1 cubic meter. So in volume and capacity, which holds more juice when full? A liter bottle or a carton measuring 6 centimeters by 10 centimeters by 20 centimeters. The volume of the carton is 6 times 10 times 20 cubic centimeters is equal to 1200 cubic centimeters. 1 liter is equal to 1000 cubic centimeters. The carton holds more juice. Converting units of area, volume and capacity. 3 hectares is equal to 30,000 square meters. 2.8 cube meters is equal to 2,800 liters. 4.35 squared centimeters is equal to 435 squared millimeters. 0.07 cube centimeters is equal to 70 cubic millimeters. 0.72 liters equal to 720 cubic centimeters. 4,000 square meters is equal to 0.4 hectares. 6,200 square centimeters is equal to 0.62 square meters. So 9.6 cl is equal to 96 cubic centimeters. 38,000 cubic centimeters is equal to 0.038 cubic meters. 5,630 cubic centimeters is equal to 5.63 liters. Units of time. Time does not use the metric system. Units of time include years, months, weeks, days, hours, minutes, and seconds. So in 1 minute is equal to 60 seconds. 1 hour is equal to 60 minutes. 1 day is equal to 24 hours. 1 week is equal to 7 days. 1 year is equal to 365 days or 52 weeks. 1 leap year is equal to 366 days. So here are some example of units of time. A machine takes 4 minutes and 10 seconds to make a toy car. How long would it take to make 8 toy cars? So 4 minutes times 18 equals 72 minutes. 10 seconds times 18 is equal to 180 seconds or 3 minutes. 72 minutes plus 32 minutes is equal to 75 minutes. So overall of the time is equal to 1 hour and 15 minutes. So this all the conversion units. So next is the Newton's law of motion, 5 samples problems with solutions. Newton's laws of motions. Background, add to notes. Sir Isaac Newton, 1643 to 1727, an English scientist and mathematician famous for his discovery of the law of gravity, also discoverer of 3 laws of motion. Newton's laws of motion. Newton's first law. Objects in motion tend to stay in motion and objects at rest tend to stay at rest unless acted upon by unbalanced force. Newton's second law. Force equals mass times acceleration, or F equals mass times acceleration. Newton's third law. For every action there is an equal and opposite reaction. Newton's first law. An object at rest tends to stay rest, and of an object in motion tends to stay in motion unless acted upon by unbalanced force. What does this mean? Basically, an object will keep doing what it was doing unless acted by an unbalanced force. If the object was sitting still, it remained stationary. It was moving at a constant velocity and it will keep moving. It takes force to change the motion of an object. What is meant by unbalanced force? So the force of the book are balanced. The table pushes upward on the book. So gravity pulls downward on the book. So if the force on an object are equal and opposite, they are said to be balanced, and the object experiences no exchange in motion. If they are not equal and opposite, then the forces are unbalanced and the motion of the object changes. Some examples from real life. A soccer ball is sitting at rest. It takes an unbalanced force of a kick to exchange its motion. Two teams are playing a tug of war. They are both exerting equal force on the rope in opposite directions. This balanced force results in no exchange of motion. Newton's first law is also called the law of inertia. Inertia, the tendency of an object to resist exchanges in its state of motion. The first law states that all objects have inertia. The more mass an object has, the more inertia it has, and the harder it is to exchange its motion. Newton's first law and you. Don't let this be you. Wear seat belts because of inertia. Objects including you resist exchanges in their motion. When the car going 80 kilometers per hour is stopped by the brick wall, your body keeps moving at 80 kilometers per hour. More examples from real life. A powerful locomotive begins to pull a long line of boxcars that were sitting at rest. Since the boxcars are so massive, they have a great deal of inertia, and it takes a large force to exchange their motion. Once they are moving, it takes a large force to stop them. On your way to school, a bug flies into your windshield. Since the bug is small, it has very little inertia and exerts a very small force on your car. So small that you don't even feel it. If objects in motion tend to stay in motion, why don't moving keep objects keep moving forever? Things don't keep moving forever because there's almost always an unbalanced force acting upon it. A book sliding across a table slows down and stops because of the force of friction. If you have if you throw a ball upwards, it will eventually slow down and fall because of the force of gravity. In outer space, away from gravity and any sources of friction, a rocket ship launched with a certain speed and direction would keep going the same direction and at that same speed forever. So Newton's second law. Force equal mass times acceleration. Acceleration, a measurement of how quickly an object is changing speed. What does F equals ma mean? Force is directly proportional to a mass and acceleration. Imagine a ball of a certain mass moving at a certain acceleration. This ball has a certain force. Now imagine we make the ball twice as big or double the mass but keep the acceleration constant. F equals ma says that this new ball has twice the force of the old ball. Now imagine the original ball moving at twice the original acceleration. F equals ma says that the ball will again have twice the force of the ball at the original accelerations or acceleration. F equals ma basically means that the force of an object comes from its mass and its acceleration. If you double the mass, you double the force. If you double the acceleration, you double the force. Doubling the mass and the accelerations quadruples the force. So the quantity of 2m times the quantity of 2a is equal to 4f. So what if you decrease the mass by half, how much force would the object have now? Like I said earlier, F equals ma basically means that the force of an object comes from its mass and its acceleration. Something very massive or high mass that's changing speed very slowly, low acceleration. Like a glacier can still have great force. Something very small or slow mass that's changing speed very quickly, high acceleration. Like a bullet can still have a great force. Something very small changing speed very slowly will have a very weak force. The last is the Newton's third law. For every action, there is an equal and opposite reaction. So what does this mean? For every force acting on an object, there is an equal force acting in the opposite direction. Right now, gravity is pulling you down on your seat, but Newton's third law says your seat is pushing up against you with equal force. This is why you are not moving. There is a balanced force acting on you. Gravity pulling down, your seat pushing up. So that is the mean for the third. So what happens if you are standing on a skateboard or a slippery floor and push against a wall? You slide in the opposite direction, away from the wall, because you push on the wall, but the wall push back on you with equal and opposite force. Why does it hurt so much when you stab your toe? When your toe exerts a force on a rock, the rock exerts an equal force back on your toe. The harder you hit your toe against it, the more force the rock exerts back on you too, and the more your toe hurts. So the next is pressure. 5 samples problems with solutions. Pressure. Pressure changes. Pressure, define the term pressure in terms of force and area, and do calculation using the equation pressure equals force over area. Pressure is the force per unit area, so pressure is equal to force over area, or P equals F over A. The SI unit of pressure is Newton per square meter, or N per meter squared. This unit is also called the Pascal or PA. So here are the some problems of pressure. The mass is found from density of air and the volume of air. So M equals PV is equal to 1.29 kilogram squared meter times 5.6 meters times 3.8 meters times 2.8 meters is equal to 77 kilograms. So assume that your density is that of water and your mass is 75 kilogram. So V equals M over P is equal to 12 kilograms over 1.00 times 10 raised to negative 2 kilogram is equal to 7.5 times 10 raised to negative 2 squared meter, or 75 liter. The pressure exerted on the floor by the chair leg is caused by the chair pushing down on the floor. The downward push is the reaction of the normal force of the floor on the leg, and the normal force on one leg is assumed to be 1/4 of the weight of the car. So P equals W over A is equal to 1/4 times 66 kilograms times 9.80 meter per squared over 0.020 squared centimeters times 1 meter over 100 cm is equal to 8.085 times 10 raised to 2 N over squared meters, or equals to 8.1 times 10 squared Newton per meter. So the pressure exerted by the elephants is found in the same way, but with all of the weights being used, since the elephant is standing on 1 foot. So the same formula, P is equal to W over A is equal to 1,300 kilograms times 9.80 meter per squared over 800 centimeters squared times 1 m over 100 cm. So is equal to 1.59 times 10 squared n per meter squared, or is equal to 2 times 10 raised to 2 n per squared meter. Find the pressure difference, the density. So P is equal to PGH, or enthalpy P is equal to PG enthalpy H is equal to 1.0.5 times 10 raised to 3 kilogram per meter squared times 9.80 meter per square meters times 1.70 meters is equal to 1.749 times 10 raised to 4 n per meter squared times 1 mmHg or mercury over 133 Newton per meter squared is equal to 132 mmHg or mercury. So the last part that I will report in this module 2 is the temperature with 5 problems with solutions. Revision of thermodynamic concepts, examples, applied thermodynamics and heat engines. So temperature is a measure of the average kinetic energy of the atoms or molecules in the system. The zeroth law of thermodynamics says that no heat is transferred between two objects in thermal equilibrium. Therefore, they are the same temperature. So here is some example of temperature. The EMF in the thermocouple with the test junction of T degrees Celsius on gas thermoscale and reference junction of ice point is given by E is equal to 0.20 T is minus 5 times 10 raised to negative 4 T squared MV. The millivometer is calibrated to ice and steam points that will thermocouple read when the gas thermometer reads 50 degrees Celsius. At ice point, when T equals 0 degrees Celsius equals 0 MV. At steam point, when T is equal 100 degrees Celsius, so the equation will E equals 0.20 times 100 minus 5 times 10 raised to negative 4x times 100 squared is equal to 15 MV. At T is equal to 50 degrees Celsius, E is equal to 0.20 times 50 minus 5 times 10 raised to negative 4 x times 50 squared is equal to 8.75 MV. Thus, enthalpy T is equal to 100 degrees Celsius to enthalpy E is equal to 15 MV. Hence, when gas thermometer reads 50 degrees Celsius corresponding to 8.75 MV, the thermocouple will read 100 over 15 times 8.75 is equal to 58.33 degrees Celsius. That is the answer. So here another example. A water in a tank is pressured by air and a pressure is measured by a multi-fluid manometer. The tank is located on a mountain at 1,400 meter altitude where the atmospheric pressure is 85.6 kPa. Determine the air pressure in the tank. If H is equal 0.1 m and H sub 2 is equal to 0.2 m and H sub 3 is equal to 0.35 m. Take the densities of water, oil, and mercury to be 1,000 kg per meter cube and 850 kg per meter cube and 13,600 kg per meter cube respectively. So P sub I plus H sub 1 P water G plus H sub 2 P oil G minus H sub 3 P mercury G is equal to P atmosphere. So Pi is equal to P atmosphere minus H sub 1 P water G minus H sub 2 P sub oil G plus H sub 3 P mercury G. So P sub 1 is equal to P atmosphere plus G times the quantity of H sub 3 P mercury minus H sub 2 P of water minus H sub 2 P of oil. So is equal to the quantity of 85.6 plus 9.81 times 13,600 times 0.35 minus 1,000 times 0.1 minus 850 times 0.2. So the answer is 130 kPa. So that is the second example. So here the third example. A rigid tank contains a hot fluid that is cold while steered by a paddle wheel. Initially, the internal energy of the fluid is 800 kilojoules. During the cooling process, the fluid loses 500 kilojoules of heat and the paddle wheel does 100 kilojoules of work on the fluid. Determine the final internal energy of the fluid. As we can see the diagram, the 500 kilojoules is going to upward while the work is equal to 100 kilojoules mo ng wheel. So U sub 1 which is the 800 kilojoules and to determine the final internal energy is U sub 2. So tank is stationary enthalpy KE is equal to enthalpy PE is equal to 0. Thus, enthalpy E is equal to enthalpy U. Applying the first law of thermodynamics, which is the energy balance, E in minus E out is equal to enthalpy E system. So, W minus Q out is equal to enthalpy U minus is equal to U sub 2 minus U sub 1. So 100 minus 500 kJ is equal to U sub 2 is minus 800 kg. So then transpose U2, and the answer is 400 kg. So example number 4. The room is initially at the outdoor temperature of 25 degrees Celsius. A large fan that consumes 200 watts of electricity is turned on. The heat transfer rate between the room and the outdoor air is given by Q is equal to UA times the quantity of T sub I or in minus T sub out, where U is equal to 6 W per meter squared degree Celsius. Overall heat transfer coefficient A is equal to 30 meters squared. Exposed surface area of the room. T sub I minus T sub O, or T sub in or T sub out, are the indoor and the outdoor temperature. Determine the indoor air temperature when steady conditions are established. So the electricity consumed by a fan is the energy input to the room, 20 watts. The increased room air temperature, however, a steady state rate of heat transfer from the room is equal to the heat input to the room. Applying the first law of thermodynamics, which is the energy balance, E sub in minus E sub out is equal to D is E sub system over D sub T is equal to 0, or E sub in minus E sub out. So steady state, where W is equal to Q out equals UA times the quantity of TI minus T0. So TOI rather, so 20 watts minus equals to the quantity of 6 watts over m squared degree Celsius times 30 square meter times TI minus T0 is equal to TI is equal to 26.1 degrees Celsius. So transpose to TI, so that we come up 26 degrees Celsius. So here the example 5, the last example for the temperature. A frictionless piston cylinder device contains 5 kg of steam of 400 kPa and 200 degrees Celsius. Heat is transferred to the steam until the temperature reaches 250 degrees Celsius. If the piston is not attached to the shaft and its mass is constant, determine the work done by the steam during the process. Use the data given in the figure for SP volume. So constant pressure or quasi-static process. So as we can see the diagram or in the figure, the pressure P and the P equals to constant. The V sub 1 is equal to 0.53434, and the V sub 2, which is 0.59520 meter cube per kilogram. So W sub 1 minus 2 is equal to integral of V sub 2 over V sub 1. PDF is equal to P times the quantity of V sub 2 minus V sub 1. So work sub 1 minus 2 is equal to MP times the quantity of V sub 1 minus V sub 2 is equal to V is equal to MV. So W sub 1 minus 2 is equal to 5 times 400 times the quantity of 0.59520 minus 0.53434 kilogram kPa meter cube kilogram. So we cancel kilogram, so mabilin is kPa, which is pwede ma-kg. So the answer is W sub 1 minus 2 is equal to 121.7 kilojoules excuse me, is the answer. So that's all for the fundamentals and basic principles and concepts to thermodynamics in module 2. That's all. Thank you.